Good afternoon, Jan.
Okay. Good afternoon, Michael.
How do you do, sir?
Doing fine. What about you?
Very well, very well. It is Thanksgiving here in the States, so we've got people coming over today to celebrate, have some turkey, uh,
Okay.
and some ham.
That's why we get all the promotions here of Black
Yes,
Friday.
yes. Yep. Sorry you have to deal with that, but
No, it's
hey,
it's
there's some
it's
good
amazing.
deals. Some good deals, yeah.
Yeah, it's amazing. I think about 10 years ago, we even didn't know about Black Friday.
Uh huh.
And the last 10 years, we are overwhelmed with all these promotions. Um,
Yeah, and there's this crazy idea called Cyber Monday that popped up. It's not nearly as popular a term
mm,
anymore. But yeah, the idea was that people would go back to work on Monday and then they would buy stuff online. But
okay.
it's like it's like people don't have internet at home. What? Yeah, it
Yeah,
was it
I
was
think
a
now
short term thing.
I think now almost everybody has internet at home.
Yeah, yeah,
Mm.
and in your pocket, you just I
Yeah.
got them right now.
Too much internet. Yeah.
Yeah, and the thing that I want to buy is probably in the warehouse that's just 7 miles from my house. So yeah, pretty soon there will be a drone just taking it from there to here.
Yeah. But if you buy something from the warehouse next door, it will make a tour around the country before arriving at your place.
Yeah, we
Yeah.
actually have had the experience of I'll buy something in the morning. It says okay, it'll ship in 2 days, and then it shows up that afternoon. Oh, okay.
Okay.
It was there. There was a truck.
Mm.
They loaded it.
Yeah, but sometimes it goes the other way around.
Yeah.
I ordered the book. It was in beginning of July, and I think it took more than a month before it was delivered.
Oh
It was a
wow.
book from Germany,
Hmm.
so it should have been there in 2 days.
Yeah.
Um, it was almost declared lost, and then at once it was there. So
Yeah. Logistics is weird.
it was not about historical modeling.
No. No, it couldn't have been a good book.
No, it was a good book. It was about antenna physics.
Oh, interesting.
Huh, that's another of my interesting things.
Yeah.
Everything that has to do with telecommunication, I I like.
Awesome. Yeah. Yeah. I'm
But,
afraid I've not really dived into that. Other than, as I understand, an antenna that's bent at right angles, so you've got the three dimensions that seems to be a good general purpose design. I don't, but
well, no, it's a lot of mathematics. So I
mhm.
think it's something that that could please you.
Yes, yes, I think it could.
Um, oh, I find it always fascinating to see that in about one century time. Yeah, it was late 1800s that they started, and
Yeah.
that the people at that time with almost no means. I mean, there was no internet to search something. There were libraries, but there was hardly communication.
Hmm.
There was no equipment. People even didn't have electricity at home,
Hmm.
and still they could make these transmissions. Uh, Beginning of the 20th century
Hmm.
across the ocean. It's amazing,
Yeah.
um, and that everything was predicted already mathematically before.
Hmm.
If you
Yeah,
see
that's very
Max,
pleasing when that happens.
yeah.
Yeah. It's like,
If
oh,
if,
this
if you
theory
see,
says that this should be true. Well, we don't
yeah,
yet have the technology to test it, but hey, let's keep working on it. Then,
yeah, if you see
hey,
the,
look
the
at that.
Maxwell
It worked.
equations, the Maxwell equations,
Yes.
yeah, you say, okay, there is an electrical field, there is a magnetical field, uh,
Hmm.
but they were never able to see it at that time.
Right. Yeah. Yeah, and isn't
Even,
yeah, I heard this might be apocryphal, but I heard that when he wrote the equations, there was one missing, and he's like he basically just translated mathematics that other people had determined into field equations,
Yeah,
and then it's like, okay, this makes it nice and neat. But then that means that there should be this other one to maintain symmetry. So he went ahead and wrote that down, and then it turned out to be true.
yeah. He added one factor to one of the equations uh,
Okay.
to make everything work,
Mm.
and he was right. Yeah, because he took a law from Faraday, and he took existing equations, and then he put them together,
Mm-hmm.
cleaned them up, and ended up with four different equations. But it's amazing that he could do that,
Yeah. And
and even the
they're
people.
so short. It's like little tiny equations.
Yeah, and if you see the people who build on it, like Marconi, who bring it to practice, um, I find that, yeah, the clever people,
Mm-hmm.
they are clever people today, but there were very clever people long before already.
Oh yes. Oh yes.
Uh,
Yeah. Yeah. I'm constantly amazed by Veritasium. They cover these kinds of historical discoveries, and it's like
mm,
one of them was one of the recent ones was about clear glass, and it's
mm,
like, okay, glass maker just decided to add this, and then the glass came out clear. It's like, why did he decide to add that? It's like they're just
mm,
playing with all sorts of things, and then properties emerge, and then it's much later that they figure out the chemistry and they figure out the quantum mechanics in this case that made it
mm.
work. Um, and it's like, oh, they're just trying stuff until something works.
Yeah, but sometimes we think it's by accident, but accidents with a certain uh, direction from the people who
Yeah.
are thinking that might be a good solution. Let's try it.
Mm-hmm.
Where
Yeah.
they have a feeling that something should work.
Yeah. Yeah, because they're probably like, I want to make blue glass, so let me add blue things to the glass, and then it turns out a different
Mm,
color. It's like, how did that happen? So, okay, I guess the color of the thing before I add it to the glass is not the color that it's going to make the glass. So maybe there's something else going on. And so,
mm,
yeah, yeah, an accident leads to, oh, don't try the thing that you were thinking about, and then try something else.
mm.
Yeah, and then it's goal directed, so you're making all sorts of accidents, but then the one that suits your goal, you continue forward with.
Yeah, but it's not a real accident. It's an accident,
Yeah,
a chosen accident.
yeah,
Mm, Good.
awesome.
That was a long time ago that we had another meeting. Sorry for last week.
Oh, not a problem at
Uh,
all.
but it was really, I thought, okay, I have a meeting in the morning, and then
Mm.
in the end, it turned out to be in the afternoon.
Yeah,
So
well, I hope it
yeah.
was a
Well,
successful one.
meanwhile, I'm still waiting for the outcome.
Mm.
Few people involved, and they are still. It takes time. We will
Mm-hmm.
see.
Yeah,
But,
yeah. Well, yeah.
anyway,
Last week, Cabbage happened to get to be able to sign in at the at the time of the stream. So um, that turned out pretty well.
I haven't seen the stream from last week yet.
Uh
Um, I've been busy with a lot of things,
huh.
and yeah, I should make a lot of progress, but so far I'm not going to say that I didn't see at historical modeling at all. I did do a few things, but not what I wanted to do,
Mm.
not at all. So the meeting from last week I haven't seen yet.
Well, there was um, so what I did. Let me. Oops. No. Wait a minute. Okay, sorry. I'm trying to get Zoom started. Or yeah, and yeah. So last week, uh, yeah, Cabbage was able to join, and we talked a bit uh, about basically how to uh, yeah how best to build a library that is going to solve a problem like a sync library or a data management library, and so he's building one in Rust.
Okay.
So so yeah, kind of talk through what was the thinking behind correspondence and behind Jnaga, and you know, even went back earlier, the peer-to-peer game engine, PPGE.
Okay.
Um, that was the Java version of this
Mm-hmm.
craziness, um, and uh, um, and then uh, yeah, how to basically take the ideas, uh, practice them with an application, and then kind of you
Hey,
pull that out.
was that your was that your colleague with who you built the game engine in the beginning?
No, no, this was
Oh,
the first
okay.
time that I met him.
Okay, no.
um, but yeah, then from there, yeah, I demonstrated a new version or a new feature in Jnaga.js, and that is the ability to purge
Mm-hmm.
facts that meet certain conditions. And so actually, this week I finished up the second half of that capability in Jnaga.js. I still need to translate it to Jnaga.net, but now it purges in real time. So I can show you what
Purge is
that is all about.
be- because the purge is for facts that you don't need anymore. For example, an employee that left the company, you
Yeah, it
don't
could
want to
be.
keep that data, so you delete it.
Yeah, it could be for that. Yes.
But
Yeah.
why would you like to purge in real time?
Yeah. So as soon as they leave, uh, then that purge will take effect, and it's localized, so you get to choose. I want to purge here, but not here. Um, and uh,
Like
yeah,
you
yeah,
make,
you build it into your model, so
yeah.
it works the way that you intend for it to work.
So if, for example, if there is a fact left the company, add it to the to that employee at that
Yes,
moment, the history of that employee will be purged.
yes,
Okay.
yes. And so that's yeah, that's great for maintaining the size of your replicas, but also for GDPR.
Mm-hmm.
So if somebody says, I want
Absolutely.
you to delete my information, they will record that request as a fact. Now you could choose to act on that fact immediately and just comply, or you can choose to have a process that you go through to review it, to back it up, to whatever. Uh, yeah, I guess backups are part of the issue. You don't want to back it up, um, but whatever you need to do to comply, and then finally you record a fact that says, okay, we're executing on this, and then
Mm-hmm.
it'll take effect. But because it's a fact, it will flow from one replicator to another, and down to the replicas of the at the edge. And if you've got the purge condition set up on each of those replicas, then it'll just get purged everywhere. Just flow through the
Okay.
system. And pop, 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 pop.
Mm-hmm.
So I'm pretty excited about this. Those are the top two questions that I get whenever I introduce somebody to historical modeling. Well, doesn't the database grow unbounded? And what about GDPR?
Mm-hmm.
So now I can say purge.
No, but it's nice that you can make it go through the network and that all the replicas will follow.
Mm-hmm.
Um,
Yeah. So let me do a share. So we will share the screen, and then yeah, I also want to grab this and get that out of the way. Pop that up. And there, now everybody else can see it. Okay. So, yeah, I should be sharing on Zoom now.
yeah,
Okay. So,
see the code.
what was that?
I see the code
Oh,
on Zoom now.
excellent. Okay. So, so yeah, kind of catch up. We've got, yeah, this is Jnaga.js. We are building a model here. So we've got classes that are, this is the blog model. So here's the
Mm-hmm.
site. I added a site deleted and a site restored, but then also a site purged. So the idea is that with deleted, you set your deleted at date, and then restored undoes the delete. So
Yeah.
clearly you can't purge when something is just deleted. It's basically, it's in your recycle bin. But then when you empty your recycle bin, you say, okay, no, I really want to purge that. Then you create this site purged fact, and it refers back to the site deleted. There's no date time, excuse me, because there's no need to try to do it again. So there is no undo a purge. It's just that's it. That's where the graph ends. Um, so then under this we've got posts and titles. So we've got things related to the site. So we set up the model where we define all those relationships. And then right here, we set up some purge conditions. So you want to purge when exists for a given site a successor site purged, where purged deleted site is equal to that site. This, by the way, is the the
New
new
syntax.
cleaner syntax. Yep.
Mm-hmm.
So that is now officially a part of the package. And so this purge condition, it it will apply. So there are two ways to apply the purge. One way is to call a method to say find everything that should be purged. Find all these site purged in the database, and then go ahead and execute that purge. So delete everything underneath that site. So you can't delete the site itself, because if somebody were then to tell you about that site later, you would think it was a brand new site, and it would pop into your application again. That's the old tombstone problem.
Mm-hmm. Yeah.
From active. Oh goodness, what was that library? That Microsoft library that
Yeah. Was it not
tried to do this.
ActiveSync?
Yeah, ActiveSync.
Active.
Yeah,
Yeah.
it had that problem, and you can read documentation about why that problem occurred. It's because they didn't keep the tombstone around forever. They kept it around for just a short period of time. So you have to have the site, and you have to have the site purged. You have to keep that around because tombstone. So you hold on to these, but you can get rid of everything else related to that site. So you can get rid of all of the all of the posts, all of their titles, anything else that might be related, like the content, the comments, everything goes except for what's in this little part of the graph. So what I demonstrated last time is that I've got this modified replicator here that that includes the purge conditions. So when we call Janaga server.create, we give it the purge conditions. And now it's able to call j.purge. And this one just calls j.purge whenever it starts up. Mm-hmm. And so let me go ahead and get it started up.
So the facts that will stay is the site deleted, and then the purge that has site deleted as a predecessor.
That's correct. Yes.
Yeah.
Yep. So just that little chain right there. So let's do npm run replicator.
And if there are other things other facts that reference to that site or to one of the successors of the site,
yeah, then
metadata.
those facts are going to be purged.
Okay.
Yeah. Um, Now there is something that is necessary to make this safe. So I forgot that I'm already running it here. So it's already up and running. Um, and now first I'm going to use the export function in order to demonstrate what's in the database. So now it's exported this as factual. Last week I ran into a bug with export, so that bug is now fixed, and we can see
Mm-hmm.
that these things are left behind. Um, let's go ahead and create a new site. So we will start with michaelperry3.net. So create sites. Let's get sites. Create site. There it is. So we'll do michaelperry3.net. And don't yet want to do the deleted or the purged. We'll just do those for now. I just realized I don't have comments in in the factual language. That would be nice. Okay, so let's post those to local. So now we've created michaelperry3.net, and we can see that right here. F9 is michaelperry3.net. So then we can create a few posts for michaelperry3.net. Send those in. What is... Yeah, it's the same. Okay, I'm not sure why I took 2 hits of the button, but... Okay. Now we've got... there's our site, F9. Now we've got a post, the title of that post, and then modification of that title. So
Yep.
that's all good. Now I want to go in there and delete it. So let's do first of all the delete and run that. So now I can see F13, the site has been deleted, but of course it's not purged. And there are 2 reasons it's not purged. One, I don't yet have the version of, the latest version of Janaga server installed. So right now I'm just showing the purge on method call. But the other reason is we don't purge on deleted, we purge on purged. So if I were to stop this replicator and then run it again, it's going to run the purge method. But because I don't purge on deleted, the data is still there. So nothing up my sleeve. Now let's actually purge it. So here's the purged. Let's go ahead and run that. And so now we can see, because I don't have the real-time one in there, I've actually captured the purged fact as well as deleted, and then we still have the post and its titles. But I shouldn't be able to ever see that post or its titles, because the purge conditions are mandatory. Here's what I mean by that. So let's get the posts. Here is get posts sans auth. So I can run this for michaelperry3.net, and I will see the latest post, introduction to the Janaga replicator. So that yeah, I'm allowed to see that post. Um, and that's because here it's looking for where um, the post has not been deleted. Actually, let me save this idea for later. There's an important idea here, but what I meant to do was show get sites. So I'm going to get sites. You can see that here we're getting all the sites from this creator. We are looking for the sites where there is not a purged fact. So purged is not there. So hit the button a second time. Or do this and then hit the button a second time. Okay. Yeah, so michaelperry3.net does not show up in the list. Um, for those that have watched the last week's, you might be wondering why these first two show up in the list, because I did purge those. That's because of a bug that I fixed this week. But it doesn't show up because I've got this site purged condition in here. And so the condition filters out anything that has been purged. Now, let's suppose I wanted to peek behind the curtain and actually see the ones that haven't been purged. I am not allowed to do that because the match is missing a purge condition. I have declared that to be a purge condition on the replicator, and so you cannot express any specification that doesn't have that purge condition if it's selecting the site.
Okay. So you can really hide the purged records before they are really purged.
Right. Right, because the core promise of Janaga is eventual consistency. So if if you can see that a purge has taken place, then it's broken that promise. So so it keeps the tombstones around in order to maintain consistency. But yeah, if you just don't look at the tombstones and try to look at what's what's inside of that purged site, then you shouldn't be able to see a difference between something that has been purged and something that hasn't. So it should be consistent in those two scenarios. The purge should be completely invisible. And so by enforcing that that your specification includes these purge conditions, I'm first of all saying that I will only purge as long as it's invisible to you as an application. Excuse me. So that is the first bit that I implemented. That was the most important bit. I want to make sure that I maintain that consistency. So, okay, so let's take a look at what's in the database, and yeah, we can still see the title is there because we restarted and then we purged. So, so the purge is now there. So let's restart again, which, yeah, this
If
one.
you export, you can still see the purge record.
Ah, yes, yeah, that's true. Because export is not, it's not the way that the application is supposed to work. So, so as long as you're within the world of the application, it should be completely invisible to you. But outside of that, you have some additional tools in order to operate a system, and so of course it'll be visible to you then. So now when I export, then I can see, because I don't have the latest version, the bug has happened. But we're gonna rerun this test, and you'll see that bug has been fixed. But you can see it's purged all of the facts related to this site, but it's actually purged the deleted and the purged facts as well, which I just said it has to keep those around because they're tombstones.
Yeah.
And so that's the reason that get sites returned. Oh, let's go ahead and put the required condition back. That's the reason that get sites returned the purged sites, and now michaelperry3.net, because since it did actually purge the tombstone, then I was like, oh, it popped back in. We have the active sync bug right here. So let's get rid of the active sync bug and make this all real time. So to do that, I'm going to npm install Janaga latest and Janaga server. Whoa, a minute. No, I am on Janaga server, so I'm just going to fetch. So let's make sure that yeah, I am in a branch. Okay, let's go back to main.
So the system does not allow to purge effect.
Right, yes. That is the intent when everything's working correctly. And now it should be. So let's rebase onto main the demo purge conditions. Okay. So we should be up to date now. So now we've got the latest code. Let's npm ci and npm run build on this. Okay, npm run build. Okay, so now npm run replicator. I should see two improvements. One, it shouldn't purge the tombstones anymore. But then two, it should do the purge in real time. So let's demonstrate that. I want to go ahead and create some posts for michaelperry4.net. And when I do that, now I have there is michaelperry4.net F15, and then we've got a post and title for that, which means if I go over here and get sites, I should see michaelperry4 show up. All well and good. And now let's go ahead and create the purge fact. So I want to run this one for michaelperry4. Let's go ahead and run the deleted, create the deleted and the purged. And bam, those are created. And now, because this ran in real time, I shouldn't see the post or the titles anymore, but I should still see the tombstone. So let's see. And here we have.
In 1920, yeah.
Yeah. So it's been deleted, it's been purged, but I no longer see 16, 17, and 18. So those three have been purged from the replicator.
Mm-hmm.
And that happened as soon as the purged fact arrived at that replicator. So now that it's there, it gets queued up for for sending it upstream. So it just flows upstream and knocks out all the data up there. Yeah, up until maybe you've got an upstream replicator that does not include that particular purge condition. In that case, it keeps the data around. So you might say, I want to clean up everything around here, but this central one, I'm still going to use the database rolling technique in order to keep archives of old data. So don't purge anything from that one.
Okay.
So yeah, you get to choose where you want to apply these purge conditions.
Mm. So a
So yeah,
purge can only be applied to a deleted fact.
that's just the way that I set it up in this model. So because I defined this to have deleted as a predecessor, that was the rule that I put in place.
Yeah.
You may decide to create a purge condition on blog site deleted, in which case that purge condition could not take into effect the restored. It couldn't say purge it where restored does not exist. Where not
Mm.
exists, not allowed on a purge condition, because that's a condition that could go from false to true, and or where not exists, yeah, true to false. But yeah, it can be undone. So purges can't be undone, so not allowed on a purge condition.
Mm.
Yep. So yeah, that is purging in real time. And yeah, just to test one last thing, the bug for deleting the tombstone was actually in the purge method. So now I'm running the purge method and verifying that that bug has in fact been fixed. And yes, that's still there. So yeah, still want the purge method, so that if you add purge conditions later, you can say, go ahead and apply them now, because I know that the the purge fact is never going to show up again. This
Mm.
thing has already been purged. So real time isn't going to help you out. You have to tell it when to do that. But then there are some other cleanup things that some scenarios that you might find yourself into where a periodic call to the purge function helps you out there. So one of those scenarios, well, this is an edge case. It's not exactly that scenario, but if let's go back to the get posts. Where was that one? Get posts. So here I'm getting the posts for Michael Perry 4.net. And so I run this. Gotta push the right button. And I get back no posts. Now, if yeah, so I did say that the purge should be completely invisible to the application, and yet here this is using things that are available to the application. I'm just running a specification, so an application could start with this particular site and see that these facts have been purged. So what's going on there? The issue is that the starting point is already past the purge condition. So I'm starting with a particular site. I am not, like if I go back to get sites, I'm not starting with the creator, because it's that step from creator down to the site that gives me a chance to add this purge condition. So if I'm already at the site, then then I can't do that. So that does open up one hole where it's visible to the application. And
I don't really follow here.
Yeah. Yeah. So the purge condition that is mandatory is the one that I specified here. Yeah. So so when exists for a given site, a site purged successor. So if I am trying to get the sites, then here I've got an unknown where I say, okay, match all the sites. And it says, I can't do that unless you have this purge condition as part of your specification. So only give me the ones where there does not exist the site purged. So that is the same as that one. And so that means if I'm running this specification, I can't tell the difference between the site having been purged and I can't tell the difference between the replica having physically deleted all of the successors of that site and those successors still existing. So the actual purge is invisible to the specification. As soon as this fact appears, the specification won't return that site anyway. So whether it's a purge condition or not, this condition means that it won't see the site. And so making it mandatory on this specification makes it invisible. This specification, however, since we are already at that site, there's no place to put that that condition. Technically there is a place, but that's not a place that I've exposed to the application. You can put conditions on givens, and then it's just going to return the empty set if the condition is not met. So I might expose that to the application for this purpose, but right now it's not there. And so that means that if you already know about this purge site, you can go ahead and look for its posts, and I can't force you to add that condition.
Okay.
And so I experimented on one of my branches with going ahead and requiring that that purge condition on the entire on any of the successors. So if you already know about the purge site, you have to have the purge condition. You would have to put it inside of the given. But going deeper, let's suppose that you already know about the post and you're trying to get the title. So in that case, you already know about a fact which is a successor of the purge root, the site. So in that case, you would have to create a condition on the given. Only do this when the post is not part of a site that has been purged. So I could, if I expand the API a little bit to allow you to specify those conditions on givens, I could extend the language in order to make it possible to enforce those. But nevertheless, that still caused a problem with the application design itself. So let me see how. As I'm thinking about this, it might not have been an insurmountable problem. But the idea is that when you're running an application, you navigate from one fact into another. You kind of drill down through the graph, and you'll find your way to a site. So you're on a page for a particular site. So if if you're already there, then if that site gets purged, you know what? That really isn't a problem because then if it were part of the given condition, then all the other machinery would kick in, like query inversion, and it would say, oh, because you've got a condition on this given, I need to update that that projection, and now it's empty. And so the user would be on the site, and then they would see that it's empty. They wouldn't see any posts; they would all disappear. whether the purge actually happened in the database or not. That's just a consequence of the condition of this specification. And then they would just have to navigate back out, and when they do, they would see that the site that they were just in is no longer in the list. But actually, yeah, the application itself wouldn't have a problem with that, because the fact exists. It's just the the application would I think would recover. Maybe, yeah, so if you're down inside of a post and you're editing that post and then the site gets purged, then the fact that you were actually on, the starting point of that particular page has been removed from your replica. Yeah, but it's immutable. So the copy of that fact that you have in memory right now doesn't get destroyed. You know, I think it would be okay. Yeah. Yeah, so I'm going to revisit that branch. I tend not to delete branches. I don't like to purge my code. Yeah. So that would require me to be able to add conditions to givens. It would require that whenever you define a purge condition on one fact, then it's required if you use any successor of that fact. Yeah, and I think that would close that loop, and the application would not be able to see if a purge actually happened. Machinery like inverses and feeds would make it appear as if the purge happened instantly, whether it actually did or not. Yeah. Yeah, I like it. So that was one of the ways that you could kind of see through things. Yeah, I will have to change one of my tests. The way that I'm testing real-time purge right now is I'm running one of these specifications to peek under the covers. So I'll have to change that to actually look at the data itself. But that's easy enough to do. Okay. I think that is everything that there is to know about purge conditions. Yeah, I really like this idea of, because the purge condition is mandatory. Basically, when you apply a purge condition at a replicator, and then you connect a client to that replicator, that client is not going to be able to express a specification that doesn't include the purge condition. Which means that now that that replicator, or that client, now becomes interested in those purge facts. And so because these purge conditions are required, that sets up the conditions for purges to propagate through the network.
Yeah.
Yeah. So you can't just say, well, I didn't know. Well, you have to include that condition.
Unless your replicator has disabled the purge conditions.
Yeah, so you can disable the purge condition, but then you still have to include that not exist condition in all of your specifications. So so yeah, you still have to be interested in the purge, even if you don't act upon it by cleaning out your own replica.
Yeah.
Yeah. Yeah, that's right. That reminds me. There is that one other loophole here that that means that you still want to periodically run the purge function. So, and I could close this loophole. I think it'll take a little bit more work, but if you if you've already purged a site, for example, but somebody else hasn't learned that you purged the site, and they create a new post. So, so that post flows toward you while the purge flows toward them, um, and then now your replica receives this post. Um, Currently, there's nothing to prevent that replica from storing that post. Nobody will ever be able to see it because everybody has to have these extra conditions on all their specifications. So it never actually shows up, but it does get stored. And since the purge already happened here, it's not going to be deleted. So, um, so yeah, periodically calling the purge function cleans those things up. So I could close that loophole by checking every time I receive a fact, is this a successor of a a purge root that has a that where the purge condition is met. So that's a little extra check that I would have to do every time I receive a fact, which more work on on that part of the code. So take a little bit more time as it's receiving information, but it's already doing quite a lot on receive. So whenever you receive a fact, it says, "Oh, is this going to invalidate any of my caches? Is it? We're going to run the inverse. Is it? Does it trigger any updates? So go ahead and trigger those. I'm going to look at all my feeds. Is there a live feed that that is interested in this new fact? Does it create a new tuple that feed should know about? And then goes and updates that feed. So lots of things happening at that point anyway. This could be one additional thing to just do that check, which would then mean, oh, I don't need to do any of the others because this is purged. I'm just going to ignore it.
Yeah, it's something with a lot of... It seems easy. You just delete a few facts, but it's after all, it's not that easy.
Right.
You have all these side conditions.
Yeah. Yeah, and this is which is why I never really thought that I would have any kind of a mechanism to delete. It's like, no, that's just too hard. But yeah, it's kind of similar to in CRDTs, in the original CRDT paper, the way that they prove eventual consistency is that they prove that the internal data structure is eventually consistent. That everybody is going to receive the same updates and therefore evolve to the same internal state. They ignore the query function. It's in the paper. So the paper says, and there's a query function that gives you the projection of the internal state. But the query function doesn't play a role in the proof. So if the query function is deterministic and you have the same internal state, then it's going to return the same results. That's absolutely true. But that's too strict. You can have a query function that returns the same results even if the internal state is different, as long as you can prove that the query function doesn't depend upon that part of the internal state. And so the history CRDT actually goes that step further. That's why a Janaka client can work with a subset of the history and doesn't have to have the full historical graph. Because I know that subset is only going to be asking these questions, and so it only depends upon this subset. Mm-hmm. So this is similar to that in that I have to prove first that query function doesn't depend upon the purge facts. And now that I've got that, I can actually delete data, which is technically going backwards in a CRDT. It's evolving to a lesser state. And CRDTs are supposed to evolve to something greater than or equal to. It's supposed to find the lowest least common multiple. There's another term for it. But it's supposed to be the state that is greater than or equal to the starting states of the things that you're merging, but no more, but still only evolve in that direction. But yeah, this one, there's no way to do that and remove bytes from a from a hard drive. You have to accrue more and more bytes in order to make that true. So yeah, I'm pretty excited about this one. This is going to solve uh, a lot of practical problems and overcome some of the reasons that people don't even begin to try historical modeling.
Yeah, that might be the solution for a lot of questions. Like you said, GDPR.
Mm-hmm.
That's a fact that we have to follow these regulations. So
Yep.
that would be a good solution.
Yep. Yeah. And yeah, one of the things that really excites me about this solution to GDPR is that in order for it to work, you have to build it into your model. You have to plan ahead how you're going to respond to a GDPR forget request. So it's not like, oh, okay, we're gonna build a software as a service offering. We're gonna ship it, and then this request comes in and say, oh, okay, we have to come up with a process. Let's, we've got 30 days. Let's do that real fast. Talk to all these right people. Okay, all right, now DBA. It's your job to run a delete script in production that satisfies this request. Go. It's like, no. That should be thought about ahead of time. It should be tested. It should be part of your and so this solution it does part of that testing for you by requiring you to have those purge conditions on every specification, and it forces you. You cannot run a delete statement. You have to do it through the application, and then if your process is multi-layered, so not just receive, request, and purge, then you're going to build that all those layers into the model. So and then because the purge fact itself is the final successor there in that chain, it's going to preserve all of its predecessors. It's going to preserve that little part of the graph that was you running the process. So now you have a record to demonstrate that we have correctly followed our documented process to comply with GDPR. We can show you all of that, and that's preserved, even though the actual information about the user is gone, and we can't recover it. Yeah.
Mm-hmm.
It's a good, it's well thought out. So it forces good, well thought out solutions.
And it also makes sure that you don't purge things which you don't want to purge.
Right.
You can only purge objects which have been foreseen to be purged in the model.
Yep. Yep, exactly. If you try to introduce this later, then you're going to get a whole bunch of, errors saying that this specification doesn't include that condition. And so you can do that. You can work through those errors, and now you know how you've impacted your system. But then, because you've changed specifications, all the machinery kicks in, and the replicators respond to those new specifications and start moving information around the way that they should.
And at the same time, that avoids that you purge the purge fact.
Yeah.
Because it's not built in. Yeah.
Yeah. Well, yeah, that is that feature. Yeah, I think I need to go help with the turkey.
Okay. Enjoy the holiday. It was still nice for you to be there.
Oh yes.
Because it was a holiday, you're still there. That's appreciated.
Yeah.
And don't forget to order online if you want the promotions.
That's true. Yes. Yeah.
Okay, Michael, then see you. Wait. It's It's not yet the 12th of December, eh? No. Okay. I will be there next Thursday. The Thursday afterwards, I risk to be late.
Okay.
I will try to be there, but I might be a bit late.
Yep.
So
Okay, that is
the 12th of December.
Okay.
So next Thursday, no problem.
Very good. All
Okay.
right.
Enjoy the turkey.
All right.
Have a good party and see you next Thursday then.
Thanks so much. See you then.
Bye-bye.
Bye.